So in this lecture we are going to study about algebra of real functions. So in earlier lectures we had studied what are real functions and what are real valued functions. So in this lecture we will be studying the algebra that we can perform on those real functions. So our first operation is addition of real numbers, real functions, sorry. So if we have a function f and its domain is set x and range is the set of real numbers, and we have another function g from x to r. Here r is the set of real numbers. So f and g are real functions where x is a subset of r. So here x is a subset of r. Then we will define f plus g. So here we are doing addition and its domain is x and range is the set of real numbers. So we will define this by f plus g. For all x belonging to capital X. So this was addition, and similarly, so we will see example of this later. First we will define this. So if we have one function x as which is defined as fx equal to x square, and another function we have g as x cube, then our f plus g would be defined as x square plus x cube. So we see if x takes a value, suppose 3, then x square, then f3 is, for value 3 we have this value is 9, this value is 27, and if we put x in this f plus g function, then we get 9 plus 27, which is 36. So this was the value of f plus g times f plus g of 3 gives this value. And now if we add separately fx and gx, we get 9 plus 27. So these two values are same, f plus gx and this. So that's why the combined function f plus gx would be fx plus gx. So now we will quickly see subtraction. So again this is similar to our addition definition. So f is a function from x to r and g is a function from x to r. Then f minus g of x, it will be defined as fx minus gx for all x belonging to capital X. So this is our definition of subtraction. So we can take the same example and see that if this is 9 and this is 27, then if I subtract fx minus gx, I get 9 minus 27, that is minus 18. And now our new function f minus g is x square minus x cube. So if I put 3 here, then we will get 9 minus 27, again minus 18. So these f minus gx will be same as fx minus gx. So this is also a very trivial case. Now our third operation is multiplication. X to r, g is from x to r. Then we can define fg from x to r is defined as so we will write fg here and here x, this times gx for all x belonging to capital X. This is sometimes also called point-wise multiplication. So if we take the similar example, we will see that 9 times 27 is 243, and if I multiply separately it's 243, and if we take x to the power 5, if we multiply these two, then we will get fg as x to the power 5. So 3 to the power 5 is also 243, or 243, and 9 times 27 is also 243. Now next we will see multiplication of a scalar. So here by scalar we mean a real number. So if we multiply a function f by a scalar, then we can define a new function, that is scalar times function. So f is a function from x to r, and c is a scalar like 3.5 minus 2.75, anything. So c is a scalar value. Then the product c times f is also a function. C times f is also a function from x to r defined by this is a new function cf. This is simply c times the result that we get with fx for x belonging to capital X. So again, this is also a very trivial case, and if we take one example, fx is x square. So f is again, suppose x square. So f of 5 will be 25. And now let c is equal to 6. Then 6f is our new function. 6x of 5. This we are defining here as c times fx. So our here cf will become c times x square. So here 6 times x square, or if we put 6 here, then it will become 6x square, or its value will be 25 times 6, which is 150. And if we multiply this 25 by 6, we also get 150. So this is also a very trivial case. So now our next operation is division, or we also say quotient sometimes. Quotient of two real functions. So again, f is defined from x to r. G is also defined from x to r. Be two real functions. Let fx and gx be two real functions. So the quotient of f by g is defined as, so this quotient is denoted by f divided by g, and it's defined as f by g x is equal to fx divided by gx, where gx should not be equal to 0, because if gx is equal to 0, then this whole ratio itself is not defined. So these were the major operations that we can perform on two real functions. So now we will look at some examples where we will use these operations. So our first example is, let fx is x square and gx is equal to 2x plus 1. So these two are real functions, be two real functions. Then we are asked to find a f plus g. So this is for addition. So we have to find f plus gx, b f minus gx, fgx, and d f divided by g of x. So we know that so we will write it as, we should write, for one example I will write the complete solution. So we will write f plus gx should be equal to fx plus gx for two real functions f So if x is a subset of real numbers and fx and gx are two real functions, then we will define fx and gx by this fx plus gx for all x belonging to this capital X. So this is our statement. And we can also write here fx equal to x square, gx is equal to 2x plus 1. So f plus g x is equal to fx plus gx, or f plus g x equal to x square plus 2x plus 1. So this x square, it comes from fx and this comes from second functions. So this should be our answer for f plus gx. So we can write similarly. So I will directly write, so f minus g of x is equal to x square minus 2x plus 1, or we can also expand the braces and then it will become this. So this will become minus and this will also become minus. So this will be our final answer for f minus g. So similarly for fg of x, so we have to write this kind of a statement before solving any question. So if the question has 4 parts, then it's not that for first part I will write this complete thing definition and then for others we will directly write the answer. So we should write this statement before every part of the question. So for B also we will write, for C also we will write. So this will be x square times 2x plus 1 and it will be equal to 2. So here, so this x square multiplies with 2x, it becomes 2x cube. Then x square multiplies with 1, it becomes x square. So that's it. So this is our solution for multiplication case. Our last case is division. Gx where gx should not be equal to 0. So here f by g of x will be equal to fx is x square and gx is 2x plus 1, where 2x plus 1 should not be equal to 0. Or when 2x plus 1 is 0, if we take 1 to other side, we will get 2x equal to minus 1 or x equal to, or better write 2x is not equal to 0 or 2x is not equal to minus 1 or x is not equal to minus 1 over 2. So we can rewrite this statement where x is not equal to minus 1 over 2. So this would be our, so for division we have just one extra condition to check. For others, addition, subtraction and multiplication, we don't need to bother much. So now I will see. So this is our next example. So we have a function f defined as fx equal to x minus 5. So this is our function. So we are asked to sketch the graph of function fx. So remember, in our earlier lectures, whenever we are asked to draw a graph, we first write the table for that. So if this is our x and y axis, so this is x, this is negative x axis, this is y, and here we have negative y axis, and this is our origin. So we can draw a table. Here we will write or x, the values that x will take, and here we will take the values that fx will take for that corresponding x. So here fx is defined by x minus 5. So if x is 0, fx is 0 minus 5 minus 5. So we will plot this. If x is 0, y is, so this is 2, this is 4, this is minus 6, minus 4, minus 2, and similarly this is plus 2, plus 4, plus 6, and on x-axis 2, 4, 6, 8, and here minus 2, minus 4, minus 6. So if x is 0, y is minus 5, that is somewhere here. So it will pass from this point. Next is, if x is 2, then we will have 2 minus 5 minus 3. So for 2 we have here minus 3. When we have x equal to 5, then we have 5 minus 5, 0. So 5 is somewhere here. So if x is 5, y is 0. If x is 8, y is 3. So 3 is here. So we can join these points. We should also write the coordinates here. So this is 8 and 5. So x coordinate should come first. 8, 5. This is 5, 0. This is 2 minus 3. And this point is 0 and minus 5. So this should be the plot of fx is equal to x minus 5. So we see that this function, its plot forms a straight line. So it forms a straight line. So in earlier classes we had seen the function for x square, it was like this, and x cube, it was also some uh, curve like this passing from origin. Then in trigonometry we will see sinusoidal functions, sine and cosine. So these are not linear, these are not straight lines. But here for this case, x minus 5, we get a straight line. So so uh, so this is our solution. We don't need to do more. But for this kind of functions, we call linear functions because these the graph of these functions are a line, a straight line. So we call these functions as linear functions. So this was one example of linear functions. So we can generalize this kind of functions. So we can define linear functions as mx. So here m is some constant and c is also some constant. So this function we will call linear functions. So if we compare it with this example, x minus 5, then we will see that here the factor, the constant that we multiply to x, we call m, and the other constant is c. So here m is equal to 1 and c is equal to minus 5. So here m and c, these are constants. So while studying coordinate geometry, we will again revisit this formula. This is the equation of a line. So we can define any kind of line using this formula. So suppose if we want to define uh, a line which is not like this but like this. So then if we make this m term negative, so for this case m is greater than 0. For this case m is less than 0. So if we see, if we had minus x minus 5, then for 0 we would have got same point. For minus 5 we would have got 0. So for plus 5, minus 5 we would have got 0 because it's minus x minus 5. So if x is minus 5, this whole term becomes plus 5. So this line would have been like this for negative slope. And if we have this m term as 0, so if m is 0, we will get a straight line. This is the case when m is equal to 0. So if we make this m 0, then we will get fx equal to minus 5. So that line would have been this straight line parallel to x-axis passing from minus 5. So we should remember that the linear function takes this general form mx plus c. So if we are given some question related to linear functions, that fx is a linear functions, and if we are given these points 8 5 5 0 2 3 or even any 2 points, and the question says that fx is a linear function which passes from these 2 points 8 5 and 5 0, then find the function f. Then we will say that linear function is of the form fx equal to mx plus c. Now putting the value of x and y. So this fx will be the y value and this c will be the constant. So suppose we are given the same question. I will take 2 points from this example. I am given 8 5, sorry, it's 8 3. I had made a mistake here. For 8 it was 3. So we are given 2 points 8 3, and take another point, say this 5 0 and 5 0. We are given these 2 points. We are asked find fx. Then we will write a linear function is defined as mx plus c. Now substituting the value of x and fx from the given points. So here this 8 is, so this is x and this is our fx, the value of function at point x. So these all are x and fx pairs. So we will write so 3 is equal to 8 x plus c. So this is our first equation. Next is we take 0 here, we take 0 and x is 5, and our next equation is 0 is equal to 5x plus c. Now we have two variables x and here m8 we are putting 8 and m5. So we have two variables and two equations. So from equation 2, 5m plus c is equal to 0, or we can subtract equation 2 from equation 1. Then on the left side we will get 3 minus 0 is equal to 8m minus 5m and plus c, right this way, c minus 5m minus c. So here this c and this plus c gets cancelled and we get 3 minus 0 is 3 is equal to this c gets cancelled, and 8 minus 5m is 3m. So we get m is equal 3m is equal to 3, so m is equal to 1. So we got the value of m. Now substituting the value of m, we can substitute in any equation 1 or 2. In suppose I substitute m in equation 1, so we will get 3 is equal to m is 1, so 1 times 8 we get 8 plus c, or c is equal to 3 minus 8, which is equal to minus 5. So here we got m and c. So our final equation would be, so we have to substitute m and c in this. So we will get fx is equal to, so what is m here? M is 1. So 1 times x is x plus c. So c is minus 5. So we will remove the bracket, x minus 5. So we got the same function that we had took in the example. So we were plotting the graph of x minus 5. So its plot was like this. And even if we are told that f is a linear function and it passes from these 2 points, then we found out the how the function is defined. So it's important to remember the formula for linear functions. So that's all for now. Thanks for watching.